Hey there, science fans! Welcome to an exciting journey into the world of gases. Today, we're diving into the fascinating world of gases and their behavior. Gases are not just random, they follow specific patterns and rules. Gases are everywhere, from the air we breathe to the bubbles in our soda. They are an essential part of our daily lives, even if we don't always see them. But did you know that these gases follow specific rules called gas laws? These laws are fundamental principles that describe how gases behave under various conditions. This law helps us predict how gases will act under different conditions, whether it's in a lab or in the atmosphere. Gas laws are at play. It's like having a secret code to understand the invisible world of gases. By knowing these laws, we can unlock the mysteries of gas behavior. Imagine squeezing a balloon. What happened? It gets smaller, right? This simple action demonstrates one of the fundamental gas laws. That's because you're changing the pressure and the volume of the gas inside. This relationship is a key concept in understanding gas behavior. Gas laws help us understand these relationships between pressure, volume, and temperature. They provide a framework for predicting how gases will respond to changes. So, buckle up and let's explore the exciting world of Boyle's law, Charles' law, and Avogadro's law. Each of these laws offers unique insight into the behavior of gases.
Let us start with Boyle's law, named after the brilliant scientist Robert Boyle, who made significant contributions to the field of chemistry and physics.
This fundamental law tells us that the pressure of a gas increases as its volume decreases, provided the temperature remains constant. It's crucial to note that this relationship holds true only if the temperature stays the same throughout the process. Think of it like a game of tug of war between pressure and volume, where one increases as the other decreases. Imagine you're pumping air into a vehicle tire. As you force more air, and therefore more gas molecules into the tire. This increase in pressure causes the tire to inflate. The more you pump, the more the pressure builds up inside the tire. As you push down on the pump, the volume of the tire decreases, which in turn increases the pressure even further.
This simple yet powerful principle is Boyle's law in action, demonstrating the inverse relationship between pressure and volume in gas. Boyle's experiments laid the groundwork for modern chemistry and physics, showing us how gases behave under different conditions. Today, Boyle's law is fundamental in various scientific and engineering applications, from understanding how our lungs work to designing sophisticated machinery.
Next up, we have Charles' law, named after Jacques Charles, another scientific superstar. This law states that the volume of a gas increases as its temperature increases, as long as the pressure remains constant. In simpler words, heat it up and it expands. Think about hot air balloons. When the air inside the balloons is heated, it expands, taking up more space. This increase in volume makes the hot air balloon inside the balloon less dense than the colder air outside, causing the balloon to float upwards. That's Charles' law, making those magical flights possible.
Last but not the least, we have Avogadro's law, named after the insightful scientist Amedeo Avogadro, who made significant contribution to molecular theory. This law states the volume of gas is directly proportional to the number of gas molecules present, as long as the temperature and pressure stay the same. This means that if you increase the number of gas molecules, the volume will also increase proportionally. Imagine you have two balloons, one small and one large. The large balloon will contain more gas molecules than the smaller one. This is direct application of Avogadro's law. This because the larger balloon has more space to accommodate those tiny, constantly moving gas molecules. The more space available, the more molecules it can hold. The Avogadro's law in a nutshell, it helps understand the behavior of gases and the fundamental and the study of chemistry and physics.